Say I have a dy dx. Let's see how I can make this. If I have, for example, dy dx equals 1 over x minus y, somehow. Right? So, what's your f? What's your little f, dude? What's f?
1 over x minus y.
Yeah, 1 over x minus y. Right, so that has to be continuous on the region that will be my answer. Well, where is it not continuous? So it's not continuous where now? Be a little more emphatic. Yeah, not continuous y equals x. So y not equal to x is not a good enough answer. That is not a region. That is saying it's not this line. It's not telling me what region. So what regions? This delineates 2 regions, right? Which are what?
Above and below.
Yes. So the 2 regions are y greater than x, y less than x. That's what we have so far. And then you can do the partial with respect to y.
1 over y squared. X times x.
So if you write it like this, it might be a little.
X minus y makes
1 over x minus y squared negative.
So it'd be like, okay, so it'd be like negative 1, x minus y, to the negative 2 times the derivative of the inside with respect to y. Negative 1. So it becomes 1 over x minus y squared, which really doesn't contribute anything else. It doesn't throw out anything else. So sometimes you'll have this guy either has no problems or has certain problems, and this guy adds more problems on top of that. So it decreases the region you can use. In this case, it kind of just agrees with that guy. So it doesn't change my answer. Those are the regions that I'm allowed, that there would be a unique solution existing. Guaranteed. Remember, if the theorem's requirements aren't met, anything can happen. And a lot of theorems act like that. Is that cool? And again, I try to use a language that would kind of clue you in to use this. I like it.
So we didn't have to like come up with a specific point and then.
No, and
Okay, cool.
which one? Oh, there.
3. Yeah.
Find a region.
Okay.
And remember, the unique solution is a function.
Yeah, the solutions are always functions. I like it for DEs. Okay.
That was part of the problem the first time I kept having it. Never was a solution.
I mean, that's possible. Well,
Yeah.
it's a constant function. Yes.
So the region here would be y greater than x and y less than x.
So it'd be y greater than x or y less than x. Yeah. So if I said, does this have a unique solution existing through the point 2, 2? No. Right, so it has a solution, a unique solution passing through every point except the ones where the coordinates are equal to each other. Yeah. There were a few homework problems that were pretty similar to this one. I love it when a student's like, your test is nothing like the homework, and then I write down the homework problems next to this. There you go, buddy. So I'm not going to copy and paste homework problems. Hopefully you're not expecting that, because then you'll be in shock. Yes?
Can you do number 42 from 2.2?
2.2?
It was 2.2.
42? Oh, yeah, 42. So you got 39, okay? Yes? Okay.
For some reason, like, it was difficult for me to integrate.
No, yeah, I'm sure there are others that will agree with you. I'm not saying this is the only way to do this, but, right? And then you got this stipulation over here. We'll worry about that later. Okay. So, this is section 2.2. Something you got to be really careful about, especially if you're going to take further math courses, is do not use anything you're not allowed to know yet. So right now, it's easy as don't use section 2.3, 2.4, 2.5 in section 2.2. Even if it works, I don't give a shit, right? The whole point of that section is learn that section stuff. Everybody with me? Later, you might hit a math course where you're not allowed to use 2 plus 2 is 4 because you have to prove it. So, I mean, it's a little bit more like, tell me what I'm allowed to know. I remember saying that so many times to my teachers. What am I allowed to know right now? So what, it's in 2, 2, so I have to separate it, pretty much. So how do I do that?
Multiply by dx.
Yeah, multiply by dx, and divide by all this business. Here, I'll do half of it. It never gets old, Jeff. Whatever. Dork. Yes.
Can you do arctan or something?
Oh, all right. So if you know some,
U squared minus 1, which is that thing.
yeah. So if you think about
U squared minus
what the
a squared.
derivative, what's the derivative of arctangent? I don't know if you guys remember.
1 over
Secant squared.
arctan.
Arctangent.
Oh.
1 over u squared plus 1 minus
So-
1.
Okay.
No.
Something like that.
Something like that?
Something like
Are you
that.
sure?
Something, I don't know. Who knows?
Who knows?
I don't anymore.
No, because tangent's 1 over 1 plus, or x squared plus 1. I think about that for a moment.
So if you're not sure, maybe you shouldn't use it.
Where's the book?
It's
No, let me say this.
1 over
Let me say this.
1 plus x squared.
Yes. Let me say this. Some of you guys are using like, number 44, I don't know, in the brief table of integrals.
1 minus.
You can only use the table of integrals when I say you can,
Yeah.
all right?
Ron,
Unfortunately
I
for
had
you.
a whole test on those.
There's a whole section, and I can't remember which, I think it was Math 280, where they focused on how to use tables correctly, right?
That was my final 280.
You don't remember that? Okay, that's fine. That's fine. It's a while back.
3 years.
So, this is not in the right form, right?
Yeah.
No.
So what else can I do? What is true about this bottom? Can I use U sub? Sure, but it's not going to get me anywhere, really.
I factor out.
What is true about the bottom here? So what if I had c squared minus 100? What is that?
A squared. C minus 10.
Yeah. So this is something squared minus 1/100th. So it's 1/10 and 1/10. So it's going to be, the bottom of this is going to be y minus 1 minus
0.1.
0.1, y minus 1 plus 0.1. So you get y minus 1.1, y minus 0.9, it looks like. You guys see that? And then you can use
Ln.
partial fractions and eventually use ln. Yeah. I don't know, did anybody else try a different method? Did anybody else try this problem? I love you guys. You know that if my office hours don't work, you can email me options, because I'm in my office more often than my office hours, because I got work to do. But if there are other times, and I happen to not have that much work at some of those times, I'll tell you, yeah, that time it works for me, that time works for me. Right? There are people that can help with this in the Math Study Center. I have to figure out exactly, specifically, do you guys, who's gotten help from the Math Study Center on anybody been to the Math Study Center for help with this? Do you know the names of the people that helped you? Or was it upstairs?
James is one of them.
James? Okay. James, you know, all right, I'm so out of touch with who's in there right now. Okay. I'm trying to get you guys to understand. I'm grading some of the homework. Some of the homework looks very, very, very familiar. It looks very similar to the solution manual, which is a problem. Unless it's just a coincidence, which I doubt. Some of the homework is not done. So I'm not sure how you guys are looking at this. The homework is when you get practice, and then you find resources to help you with the homework so you can get full practice. The test is coming. The test is Wednesday. I ain't changing a damn day. Because you made it to this class, you should have some kind of study methods. I didn't think I would need to spend time on study methods. but I feel like you guys aren't, studying fully. A few of you guys are coming to see me in the office. That's great. You can have specific questions. You can have general questions. I love it. But not many, right? And I know there should be more. And you're sitting there saying, is he seriously lecturing us now? Yeah, you're my students. I want you to do well, and you're not doing for yourself what you need to. So if you're in this seat right now, that means you pretty much are committed to the class. So I would hope that means you would follow through. I don't know. Sometimes some students are sitting there, I'm not sure what they're thinking because they're not doing anything. All right, I'm not saying you're not doing anything. I'm just saying there's probably more you could do. There's more resources available to you. Is everybody kind of decent with what's happening up here? I mean, what would help me, what would allow me to do a U sub here is if the top had a Y. Really, I mean, you could let U equal Y minus 1, but then you really haven't helped yourself much, to be honest. You make this step a little bit easier, because now it's a U here. You might even want to do that so you don't have to deal with these ugly numbers. I mean, there's nothing wrong with that. If you let U be Y minus 1, then du is dy. It's a beautiful straight, you don't need anything. You're not missing anything. And then this step is a little bit cleaner, right? So if you want to do that, it's beautiful, but the U sub doesn't actually let you escape this. Right? So don't be too optimistic with things. I appreciate the idea of trying to escape something ugly, but sometimes you just can't. Is that enough to get you started? Whoever asked that question?
Yeah.
Okay. I mean, what'd you guys get for number 39 in that section 2.2? 39 is a little bit interesting when you try to work it, but you can't forget the easy answers. What do I mean, the easy answers? So, if I divide and multiply, I got to use partial fractions on this and stuff, right? But what are the two easy answers? Uh-oh. Y equals 1. Y equals negative 4, yeah. So if I had y of 0 equals negative 4, I am not going to do any freaking work. Right? Because y equals negative 4 is a solution, and that meets the initial condition. The initial condition. So number 39 is autonomous. It's got a critical point. It meets the initial condition, so that's it. 42, that stupid little minus 0.01. The whole point of this problem is you throw some little tiny perturbation in there and it really screws up the solution. Because it's got to go through some craziness to try to get through that point, right?
How did you get y plus 4?
Example.
Oh, okay.
Sorry. Yeah. So number 39,
It's this,
39. I didn't want to do 39 for you. You can see now. Yeah. Okay. Sorry. I try to avoid doing too much of your work for you. But that's the idea. The idea is that, and sometimes you just forget that. We get so focused on like, oh, what form is it in and what method do I use? And I don't blame you because that's what I'm like blasting you with. But don't forget to take a second and see, is there a simple solution? Yeah.
So 42 is the one that you did first. I multiplied it by 100, then I had 11, and I had 9. So because you asked me if there was any other ways that we done it.
You multiplied top and bottom by 100?
Both sides. I think maybe before I did it at some point. At some point I did it and I got the right answer. Which it was in that form.
Okay.
And I got the-
Sure.
It worked.
Okay. It doesn't really, changing the order of these numbers doesn't really change the idea as long as you change it back at the
It
end.
just made it more clear to see it, I guess. At the point. Because I started doing the factoring. And I said, wait. It's like-
Yeah, that's what I was
like
saying. You could
three
use U sub to make it a little bit easier.
Yeah.
Yeah.
Three brackets, like the first bracket, then the second bracket, then the third bracket. I got 9.
Doesn't always work though. As I found out with one of the problems earlier, complete that square.
Oh yeah, completing a square doesn't work all the time. Only when the top helps you. Okay. Yes?
For homogeneous, which one do you decide to substitute for?
Oh, all right. So sometimes it's just the way you happen to see it first. Because if you try to figure out what's going to be easier, you might be wasting time doing that. Instead of just trying it and seeing it doesn't look good and trying it the other way. Because that's part of the process is try something, it doesn't, oh, go back and do the other way.
Yeah.
But there are some, like, for example, I think last time it came up, remember we did the problem and I said if you did this, you'd have to FOIL, and if you did this, you don't have to FOIL. So you don't pick up, like, extra terms. And that's not even that big of a concern, shouldn't be. But that is one tiny deciding factor. Do you remember that problem we did?
Yeah.
Yes.
Yeah, if I pick the right one, then it's not like there was just a y in front of a dx or whatever, and then a whole bunch of crap in front of the dy. So if I chose correctly and had this be itself, and this was equal to u dx plus x du, then I wouldn't have to FOIL if I did it the other way. Yeah. All right, maybe. I mean, that's one tiny thing. But so many times, there's just nothing that tells you ahead of time it's going to be easier one way or the other. So many places in mathematics, you just have to try it, see it doesn't work, and then do it the other way. I mean, that's just a part of the process. And 176 is where they're supposed to instill that in you. Trig identity. Let me start on the, oh shit, all right, let me do it. And it's not like, oh shit, I suck, what the hell, I don't know anything. No, it's just, that was a mistake. All right, I didn't know it was a mistake until I got there, so let me do the other side. Let me try the other identity, right?
On a test, will you give us partial credit if we just mess up one part of it?
No. Yeah, of course. Yeah. I've done that on the quizzes, right? I give you partial credit. So depending on the severity of the mistake. If you make a stupid little mistake at the beginning, everything else is wrong, but you do everything else conceptually correct, you'll only lose a couple points at the beginning.
Yeah.
Because that's why I don't believe in Scantron. Scantron's complete bullshit. Because you could totally understand something, make a human mistake, and then just get no credit for it. Yeah. Sounds like you have personal experience with that, Jeff.
So say we forgot to like substitute back for the homogeneous
Oh, yeah.
Bernoulli's,
Oh, yeah.
how much would you take off?
Since that's so big.
That one's kind of a little higher level than just saying 2 times 3 is 5 or something. Because I don't think anyone here believes that, but our brain can do that to us sometimes, right? I couldn't tell you how much you would lose. It depends on how many other steps there were. But that is kind of a big step. Your answer can't have something that wasn't in the question, or else, it's not valid, right? Is it?
Yeah.
Yeah, because you and your whatever is your own middleman work. Is not what I want to see in the answer, because that has nothing to do with my question. So you got to remember to take it back to the original variables. And I'm not going to grade harshly if there was some simplification you could have done and you did it, unless it's something that's just, you got, like I said, the 1 over y, just flip that dude over, flip the other dude over. If it's really something obvious, then yes. Otherwise, I'll just make a note. Okay? Yes?
We go over number 18 in 2.5.
Oh, okay. So one reason why I do want to spend some time on this handout where the first step was for you to identify the different forms that the things are, which ones are linear, which ones are exact, is because that's a huge part. So all of math is like that. I think I showed you the factoring example. You learn all the methods of factoring, and then how do you get tested on it? A mixture of all the factoring methods. So a step that sometimes teachers skip is, how do I tell when to do what? Not just here's how you do this, but how do I know when to do this, right? So I'm going to give you a mixture of things, and you have to be able to identify when to do what. So number 18... Section 2.5, this one's all right, so first question I'm going to ask you is this in a form that is legitimate to try to determine what to do?
No.
No.
No,
What's wrong?
you gotta get rid of it.
You gotta get rid of x on the right-hand side.
Gotta get rid of which x?
Just the right-hand side.
Divide everything by x.
Yes, divide everything by x to get rid of this x.
Yeah.
Right? I like it.
Yeah,
Because this looks like it's almost a form, a certain form, like maybe it's linear, or maybe everybody should realize it ain't, but if I divide everything by x, I get my dy dx by itself. What is this identifiable as?
Y squared.
Oh, that's the integrated.
No. I mean, this is your p of x, right?
Yeah.
So it looks like it wants to be linear, but this is why I was talking to somebody earlier. They say, how can I tell Bernoulli's versus something? Bernoulli's is one of the easier forms to see. Because it's like it's almost linear except for the power on the stupid y. Right?
So
Not
this-
sine y. If it was sine y, Bernoulli doesn't help me out worth shit. It's just got to be the wrong power.
So that's the difference between Bernoulli's and the integrating factor, is Bernoulli's works.
Bernoulli's means it's not linear, because I use an integrating factor when it's linear. But once I do what Bernoulli's method says to do, it becomes linear. Yeah. You guys?
but your end result for most all of them is you want to be separable or linear.
Yeah,
It's one of
a lot of the
the-
processes get us down to one of those two.
Yeah.
Because those are the two that actually have real good, strong methods to actually get to the answer.
So what I've been doing, like when I start, I ask myself every time, even if like when I was doing this homework, the early stuff, on all mine right before I say, separable, linear, homogeneous. Is it one of those? 'Cause
Okay.
you could use Bernoulli's and one thing could make it easily linear.
Sure. Okay.
So it doesn't have to be like a y squared. I'm an idiot.
It doesn't have to be what?
A
Sorry.
y squared, because I was like, this doesn't make sense because these aren't squared. And then
Oh, it could be y cubed, y to the
Yeah.
18th. Yeah.
It's white to the end.
Yeah. Because what's the substitution that I make
U
in general?
equals Y to the
It could be the
One
1 minus
So if I
n,
see y to the n, let u equal.
Y raised to the 1 minus n.
And of course, that's down on the bottom, page 73.
And that's the integrating factor, right?
So in this case, n is, no. That's not the integrating factor. This is a substitution. This is related to u sub, but you got to realize, I mean, it should make sense that the minute I start doing differential equations, which has derivatives related to other things, in equations, u sub is there, but it's going to be a little bit more difficult. It's going to be a less in your face. But that is a u sub, really. It's just not immediately obvious. 180 u sub is easy because everything's kind of like, I can get everything down to separable. Everything in freaking 180 is separable. So it's, the u sub there is easy. It's not separable, shit. So how do you go from there? So let's see, n is 2, right? So u is going to be equal to y to the
One half.
1 minus 2, negative 1. And then I suggested to you to turn this around before you do derivatives, because then you can just solve directly for dy dx and replace it, right? So that's y equals d negative 1, so dy dx equals so in place of this, you put this, and in place of y, you put this. And that makes it become what? What it wanted to be in the first place. It wants to be what? It just wants to be linear, but that's stupid. And then Bernoulli said, don't worry about it.
Erase it.
Yeah, not quite that good.
Okay.
So then you,
So I mean, let's just do one more step. So this will be, just replace it directly with that, right? Negative u, negative 2, du dx. Oh my gosh, poor little dude. Oh yeah, you're good. Come here. Oh yeah, dude. All right. And what I would, well, let's see if you pick up on this. Y, I replace it with u negative 1. Y, I replace it with u negative 1. And so those will kill each other, right? If I multiply everything by
Needs to be to.
negative u squared. I could divide it by u negative 2, which is multiplication by u positive 2, right? So negative u, so I multiply everything by negative u squared plus what am I multiplying by? Negative, that's why that became plus, u squared. So what's u squared times u negative 1? U. And of course, negative u squared times negative u squared times u negative 2 is negative 1.
You multiplied, not divided?
Second?
You multiplied and not divided?
No.
U to the negative 2
Remember,
is on the bottom.
hey guys, you should be at the point where you realize there is no division, right? There is no division.
Adding and subtraction, that's all math is.
Division is multiplication by the reciprocal, so yeah. Yeah.
It's an illusion.
There's no multiplication either, it's all adding and subtracting. That's it.
Don't bring any Doug Henning in it. Math is an illusion. Might be a little too old a reference for you.
Was it invented or discovered? That's the question. Was math discovered or invented?
All right, now is this in linear form?
No.
Yes.
It's pretty.
What's P of X?
Integrating factor.
Yeah, and I can use the integrating factor, P of X.
1 over X.
Yeah, is 1 plus 1 over X.
Or X plus 1 over
Now you can do the e to the integral, and that's as much as that homework problem I'm going to do for you. You should be able to finish that sucker out. But see, this is what I mean. You have got to not so much memorize this shit, but understand why it makes sense. Or at least what the purpose is. What is it trying to do? What does the substitution try to do? Makes them as almost linear, except for the power, into a linear. That's what it's trying to do, yes?
Can we talk about what happened between y equals u to the negative 1 and the
Well,
next-
so remember, y is a function of x, u is a function of x.
Uh-huh.
So when you do this side, you have to do, this is a u here, right? I don't know if that might be a little, you have to do chain rule. Negative 1 comes down, u negative 2, but then u, the inside function, gets a turn. I like it, I like it. Woo. Okay, okay. So Bernoulli's is one of the more easily identifiable forms because it's not linear. But you have to be careful. It's got to be not linear in a polynomial kind of way, and not polynomial, just a power way. Right? If this was negative 4 and it would be negative 4, you would go to town.
So if that was like y to the 2 to the x, that would also meet the requirement?
Say it again.
Raise your y squared to the next power of x. Would that be?
Raise
considered
y
a-
squared to the x?
Yes.
No. Good Lord.
Okay, so I'm just making sure. I haven't gotten quite that far, I just started out last
No.
night.
No. Y to the 2x is, you don't want to deal with that.
We're going to learn how to.
Now he's thinking about putting it on the test. That'll be the hard
You're
part.
well, yeah. Let's spend the rest of the time learning something that's not going to be on the test. No, I think probably not.
I said I just hit the Bernoulli section last night, so.
So I don't know. Did you guys try this thing that I have an answer key for?
Yeah, I tried.
What is
it.
that?
Okay.
I did.
Let's talk about it. Let's even if you didn't try, you have a copy. Bring it out because this is important. Even if you didn't try it, I don't care. Yeah, I care, but bring it out.
Hurt his feelings and-
Bring out your papers. I'm not paper. Okay. So can you just, even if you haven't done this, and if you have, just kind of do something else. Can you look through and see which ones are separable? Can you identify the problems that are separable? And you can work with other people near you if you want to.
Is that exact the same thing as separable?
Say again?
Because there was one question in the homework said that true, false, your separables are exacts.
Oh, okay. No.
No.
It's, if you were trying to create an exact equation, would that be easy?
No.
Why? Because you have to make sure
The initial.
the partials would meet, match. If I wanted to make a separable equation, is that easy?
Yes.
Hell yes. That's very freaking easy. Now that by itself should kind of tell you that they aren't the same. The fact that exact has so much very specific requirements, whereas separable, you just got to be able to get your y's and x's apart. That's all you got to do. Exact, you gotta make sure the partials of each one and the right thing has to match. Oh my God. It's not
They
the
meet at a
easiest
point-
thing in the
they meet
world.
at a point.
Huh?
They meet at a point.
Meet at a
They're
point.
being equal, they meet at a point. It could be a function or an equation, but at that point they would intersect.
All
Sort of
right.
like graphing, right? As the DEs of the original, they should intersect at a point relating to that function, right?
No. You mean for exact? What
Yeah,
parts
so
of them?
let's say like,
So only number two
your
is-
dy, your m of n, your m
Yeah.
equals like 2x over, y equals n. That's a
Four is exact.
section of function that they would need, right?
He's exact.
Or would relate
Because
to
if
a
it's a
point.
partials on both, and
No, no.
can't really be equal.
But
and
I've been
on the-
trying to think what that equal, I
That's
understand
what
why you
that's
want to
Oh,
equal,
if
but
you
like,
take,
or
if you
that
take
y thing.
and with respects to
With that,
The
like,
partials, it's
I'm thinking
one.
from graphing, and I don't know.
Oh, okay.
See where I
Uh,
come from, in math terms,
it's hard to think that way because
So
it,
really go
it
to each
involves
one and do the
taking
partials first, to know which one is
partial of
exact
y,
and not
partial of
exact.
x
yeah.
to a given function. And so that deals with the slopes in these
Yeah.
90-degree directions, right?
yeah,
So it's not going to have anything to do with any specific points.
I said point, but that's what I was saying,
I
you
know
travel
I know number
along
one's
a section of
homogeneous.
that function, both
Is
the
it-
m and
is
y
it number
functions.
two,
Okay.
homogeneous two?
Because they would kind of, like, they may diverge, but they kind of.
Yeah, if you,
Kind of like a tangent line.
your
would be the best way to
m,
describe
if you
it.
move from your m in the y direction, if you move from your x in the, from your n
You
in
see,
the
like-
x
like
direction,
sine, cosine,
they
functions,
have to
offset and they
equal,
could kind
yeah,
of
okay.
run each other for a little bit. It could be a point, or it could be a little section where it's really, really close.
No, that's, yeah,
Dunno.
it's autonomous, not homogeneous.
Isn't
We're trying to
that
get homework
number,
done.
Uh,
Only have so
number
much time in
two.
the day.
autonomous
Not
equations are always what? Always what's method?
Automatic.
Autonomous are always what method? Besides, getting the easy answers, how do you find the general answers? Autonomous, you can always do what with them? There's no x's in them, so you can always separate them. They're always separable. They might be something else too, but they're always separable. All right, sorry. Just went through that. I heard you guys talking about autonomous.
Just to clarify.
So which one? Oh, yes.
With the homogeneous, it's the separable
I like the
homogeneous.
homogeneous. We're going to make it. I like this. It's like a Jewish holiday. Happy homogeneous. So which one? Sorry?
No, just. The homogeneous, it's the separable, not like equal to zero.
that's autonomous. Isn't that the separable one?
I don't know.
Autonomous is always separable,
Yeah.
right? Homogeneous, unfortunately, has two meanings.
Which is
No,
This
no,
one-
I meant, the substitution, not separable, like it's the thing that we did. last time.
Substitution, yeah.
Yeah.
Homogeneous is the substitution x
Okay.
over y or y over x.
Would that
Exactly.
be number one then?
Okay, hold on. Separable. I heard 2 and 3. Is that it?
Isn't 4?
4 is desperately separable, right? Totally. Do you guys see that? 4 is almost a definition of separable in a way.
But I think
It's
exact
also
would be
exact
wrong.
though too.
Okay, now careful. Now let me just get, so separable. Which ones are separable? 2, 3, 4. Any more that are separable?
There's the back.
All right, good, because that's all I got.
Yeah.
What about exact? Which ones are exact?
4?
4 I agree with.
I was gonna say 6.
Yeah, I think
6, what did I change 6 to? That's the one I changed and I forgot I
I
changed
was
it.
doing the partials first.
Here we go.
Hell no. I
For 6 to be exact, yeah, 6 is not exact. Yeah, if you try to do that,
It's homogeneous, isn't it?
yeah, 6 is homogeneous. All right, now let's just stay where we are. I heard 4 so far, right, for exact. What else? 4 is exact, I agree. 4 is like, the easiest way to make an exact equation. It's kind of like the most boring exact equation because partials are each just 1, right?
They could be
X dx plus y dy is also exact because the partials are just 0. So they equal each other. I guess everybody's kind of with me? What else is exact? There's 2 other ones besides number 4 that's exact. And they're the ones that are not in the right form. So this is why Normally what I suggest is you go for the first thing you notice,
Is 5?
because you could waste a lot of time trying to put it in the right form to see something else.
Is number 5 exact?
What do you guys think about number 5?
I haven't like worked it out yet and rearranged it, but looks like it might.
So if you look at number 5, x, y, dy, dx, plus y squared equals 2x. So you multiply by dx, you get xy dy, and we subtract it over 2x minus y squared dx. So the partial of this with respect to
Y. X, I mean.
x, so that would be
Y.
y. And the partial is with respect to
Y.
y,
Negative 2Y.
negative 2y, so not exact. I like it. You guys with me? So exact is to me, if it's not in that dx, dy separated form, I might not waste my time trying to put it there if I see it in a different form. Because that's like some time to get it here, and then some time to check it, and then it's like, isn't that? If I saw it was in another form, I might just go ahead and attack it with that. Yes?
But can you also make it from a non-exact to an exact?
Yes. But I'm not going to make you know that. I'm not going to make you memorize how to do that. But if you want to, that's fine.
Well, that's just extra credit.
Because sometimes it comes out really nice, and sometimes it comes out
Messy.
remarkably disgusting. So it's anyway. So I'll let you
Okay.
memorize that if you want to. What else? So what did we get so far? We only got 4 still?
Yeah. 3?
3. Yes. 3 is now the thing that trips people up is that. Hopefully I didn't just do that, sort of, but oh well, I did, sort of, but it wouldn't have worked out anyway because the extra 2 in that last one. But what's wrong with leaving it like this and taking derivatives right now?
It's what we need.
It's got to be equal to 0, right?
Yeah.
So then you go x plus 1 dy plus y minus 10 dx. And then, of course, yes, it's exactly like the other one in that case because the constants don't matter worth shit. Okay, I like it. So that one's exact. So we got 4 and 3. And there's one more. It's the one that's closest to number 4 in a way. Number 1. Number 1 is exact. I like it. So exact. So what do you got so far? We got separable. 2, 3, 4. Exact. 1, 3, 4. So you see that I said that earlier. Sometimes exact can be separable. But don't assume separable is exact, because exact has all those requirements that it needs, right? Separable is just like, can you get the y's and x's? So what about linear? This is a loaded question. Because how can you be linear? You can be linear in y or x, exactly. So, like number 1 is going to jump out at you, hopefully, because they're all to the first power. If you bring them up, nobody's on the bottom. There's no problems anywhere. Number 1, definitely. Number 2, quickly no. Y squared.
Y squared.
Screw number 2. So what's number 2 could be? Y squared. That's the only problem with it. Try to be linear, right? So what's number 2? Bernoulli's. Okay, I like it. I'm kind of violating my own rule of sticking with, oh, well, I don't care. What about 2, though, in terms of x? Linear. Number 2 is in terms of, let me make sure. So 1 is in both x and y. 2 is in terms of x. Or is 1 in x and y? Let me be careful. Let me slow down. If you do dy dx equals 1 minus y over x, is obviously linear in y. Is it linear in x?
Yes.
So if you do, so let's see. Let me bring it back to what it was. So if you flip it, is it linear in x?
Yeah.
Why?
But there's no square terms or anything.
Yeah, but where is there an x? Yeah. So when I have dy dx, y has no problems. It's all good. When I do dx dy, not so much.
So a dependent variable on the bottom is not linear.
Yeah, because that would be y to the negative 1, or something
yeah.
dependent on y to a negative 1, which is no good. It's not linear. Yeah. I like it. All right, where are we at? So 1 is only in terms of y. 2 is only in terms of x. What about 3?
Why it is.
There's no problem in Y.
Linear and y.
Yeah, it's already kind of set up to see there's no problem in y. Is that cool? Because you just got to divide by x plus 1. Now, if I want to check x out, I just have to flip both sides like I just did, so I get dx dy.
That puts an x on the bottom.
There's no problem.
Yeah, so let's see. It'll be
Yeah, so
dx over dy equals 1 plus x over, where'd you go? Negative y plus 10. Is that linear in x? Yes, of course. The x is up here, no problem. So it's x and y for 3. You guys start to see what I mean by, if you notice it is definitely in a certain form, it might be better just to attack it, unless you really don't like that form. Like, I don't understand that form at all. I mean, then you can maybe mess with it, because see, messing with it takes a little bit of time. And then you can misidentify it, you can do something wrong as you mess with it, who knows? Now, I'm not saying the way you see it first will always be the easiest way, but at least you see it, and you know how to attack it, you do it. You don't waste time trying to put in another form, making mistakes, who knows? Is everybody cool with that one? What about 4? Did we already talk about 4? I mean, 4 is just awesome. And it's because of the fact that when you solve for dy dx, you're going to divide by x. If you solve for dx dy, you're going to divide by y. So it's always good in the dependent variable of the moment. So 4 is good in x and y. 5?
Not in.
Yeah, 5 sucks. And then 6, I changed 6, but I mean, hopefully 6, it's really obvious that it's dead on arrival. Or it's got a bunch of natural logs and everything. Screw that. If they all go away, but they don't. All right, so what about homogeneous or homogeneous, whichever way you like to say it?
Number 1.
1.
Wait, what's the definition of homogeneous again?
All right.
the same.
So homogeneous means, now the book goes through an interesting, now to me it just means that can you make a ratio show up repeatedly? Y over x, x over y. So even if I had something, for example, if I had something like this, dy dx equals x over y minus y over x plus e to the x over y. Is that homogeneous? Yes. If I let u equal x over y, that would be u to the negative 1, and that would be u. So even if it's the wrong way around, it's still dependent on u. It's still dependent on the substitution I would use. So as long as you can make the ratio show up, and the minute there's something off, oh shit, it's dead. I can't replace for this and not have a y in it now, because I don't have the complete ratio. Do you guys?
So basically, if there's anything that you can make a substitution and it's in each term.
So there's no variables left out of that substitution. This guy would be left out, because he's not a complete ratio. Okay, I like it. So number 1, if I just divide both of those by x, I get 1 minus y over x. So 1 is homogeneous. 1. So 1 is exact linear homogeneous. 2 is separable, and so forth. You guys see what I mean about there could be several different forms. Where am I at? 2. What about number 2 for homogeneous? Oh, hell no. There's no other x's to do anything with. It's autonomous. What about 3? There's no way, right? Do you guys see that? Because if you divide by x, you get 1 over x. It's dead. It's not going to work. 4?
Yeah.
Yes. 4 is beautiful, right?
And so that's only with dy dx on one side.
Oh, yes, yeah, all right, so,
Or DXDY, whatever you want to use.
yeah, in fact, that part doesn't even matter, to be honest, but, yeah, so either dy dx or dx dy, but then you have to have those ratios show up everywhere. I like it. And it could even be, in fact, it's normally used like this, right? I like it, I like it. Let me see, where am I at? Number 5? Hell no. You guys see that? Divide by x, y, and, you know, it's screwed. And what about number 6?
Probably not.
No, it's not.
6, I love 6, because the answer is yes to that.
Yeah, I was gonna say,
Okay.
What is ln of x minus ln of y?
Uh,
ln of x over y? I mean, that's a big clue that, hey, it looks like you're
that's
trying to
what I
make
did,
some
I just kinda
ratios.
counted the big.
You got that
crossed
extra
out.
y in front of the first one? Isn't there an extra x in front of the couple of the second ones, you know? And then you can divide by y, and the last y cancels. So yeah, it's homogeneous. Thank God, because that's actually the only form 6 is in, I believe.
Wow.
I've been wrong before, you never know.
It's
So,
the same things, I saw those X and Ys and went, wait,
what about Bernoulli's?
all of them technically? No, okay.
No. 2, 2 and 5. Yeah. So Bernoulli's 2 and 5. I like it. So now you would just, so now we can talk about, well, what methods, so one thing is to identify. So like, what would you use for number 1? You could use exact, you could use linear, or you could use homogeneous. So it's,
Exactly, easy, just be like,
I used exact, right? And I said, I choose exact. I choose you, exact. Kind of happy you guys didn't do that. I'm kind of sad that I made that reference. So number 1, I chose exact, but you don't have to do exact. I mean, which way would you guys want to do number 1 if you saw that on a test and you saw that it was homogeneous, right? So really, right now, I need your help in determining what to focus on for you. I need to get, if nobody's saying anything, then you have control. You can say, I need you to focus on this shit, and then we'll do it. Because we have not much time.
We do more of homogeneous.
Okay, sure, yeah. In fact, let's go ahead and do number 1 like homogeneous, and then we'll do number, which one, 4? No, 4 is separable, that's too good. Yeah, we'll do 6, because that's the one that looks like it's heinous, right? And it really isn't. So let's do 1 and 4, 1 and 6 homogeneously, just to make up an adverb. So number 1, what would be, can you guys take a minute and try to put it in the right, well, I don't know how to make that much easier. I mean, all I got to do to put it in the form for homogeneous is, already said it, right? Divide. And then you can do, if you want to, you can bring that sucker up there. Doesn't really matter. Because to be honest, if you left it like this, all right, let's see if you guys, because I think the procedure I showed you was built on that being there, but what would I do? I'd let what?
U equals y over x.
So that means that y equals ux, right? So what's dy dx?
U dx plus
So see, that's where it breaks down, right? Can't really, so that dy equals u dx plus
x du.
x du. So then you do bring that up. So now you see why we do that. Technically, you could divide everything by dx and all that kind of stuff if you want to, but
And that's
It's up to you.
Number 1 now.
So this
Number 4.
becomes,
so now this goes in here, which is nice. We naturally chose the right one. It just kind of fell into the right one. Do you guys see what I mean? Because now I don't have to. Now this is just itself. Except here I'm going to put.
U.
Yep. So your 1 minus u. Got it. Dx.
We fold. We distribute dx to.
Yep. So then I get dx minus u dx. So I get 2u dx minus dx equals negative x du, or you can turn that around. Gonna change my mind here? Plus negative? Is that all right? So now I have 1 minus 2u. Oh no, Jeff, what are you doing? So now, what has to happen once I do this? What has to be true? It's got to become separable, right? So can we separate this? Yes. Because you're good, Jeff. Go ahead. I kind of forgot what I was doing in the middle of it. So now this goes down, this goes down. Beautiful. So that's the other thing is, I know people always hate me because I dare to tell you that you have to remember this stuff. But if you just look at it as memorization, I agree. That's kind of crazy. You got to look at it more as understanding what the purpose of things is, right? So this tries to make it separable. So now I get dx over x equals du over 1 minus 2u. And that's relatively easy to integrate, right? Yes?
Can you explain again why you erased the dx from a bigger dy equals dx plus 6?
I just multiply the dx up. Yeah, so then, because I have this, so I could put that, replace that with this. All right, now, I could have divided by dx, all of these, and replaced dy dx with this. It would have just made it more steps to get things together. Does that make sense? It's better to just make this one single line.
Would the right-hand side be ln of 1 minus 2u divided by 2?
Yeah, so obviously here you get ln of x.
Yeah.
Over here you get, it wants to be ln of 1 minus 2u, but the derivative of this would be 1 over 1 minus 2u times negative 2, so I need to have a,
Divide by negative 1.
yeah, so I need to have a negative 1/2.
Do you solve for a variable or you plug back the...
Okay.
Yeah.
You gotta, the minute you do the integration, you gotta put it, you don't put it at the end. It's not allowed anymore, because in 180 you can kind of get away with, oh yeah, but I punched C there. Because now the C is gonna get sucked into whatever I've gotta do. Now real quick, you can't stop there, right?
You better replace you.
Yeah, you better at least replace u with y over x. And that is just beautiful.